Hey y'all, it's Miss V and welcome back to another video with me. So today we're going to continue our exploration of Pythagorean theorem, and we're going to go ahead and take a look at some more application problems. So Pythagorean theorem is one of those things in geometry that is super applicational. So we're going to constantly do application because we can actually do it for this kind of theorem, okay? So the Palace of Peace and Accord in Astana, Kazakhstan was built in 2006. The building has a right square base pyramid structure. Okay, so a pyramid is obviously a 3D shape. And if you think of like the Pyramid of Giza or all of the pyramids in Egypt, right? In this case, Kazakhstan, the pyramid in Kazakhstan it has a square as the base. Okay, and all of the corners of your pyramid essentially line up on one place like that. Wow, y'all, my pyramid came out great. Okay, so that's the pyramid right there in Kazakhstan. Almost erased it. So the length of a side of the square base is 62 meters. So we know since it's a square, right, all four sides are going to be exactly the same. So let's go ahead and label that on here, right? And then we know that the vertical height of the pyramid, so if I were to go from the top of the pyramid and go straight down to the very bottom of my pyramid right here, that vertical height is also 62 meters. So over here with the vertical height, you're going to make a right angle like so. Okay. So that height, I'm trying to point it out right there, is 62 meters as well. So if I want to, right, we're trying to find the slant height of one of the rectangular faces. So essentially, I'm trying to find this height over here, right? So I can go ahead and pull that right triangle out of the problem. And we know here's the right angle, right? We know that the vertical height was 62 meters. Okay, so this right here, this is the top of your pyramid. And then this right here is the bottom of it, okay? Or like the very center of the pyramid. But we know that that vertical height, it's not like measuring the entire side of 62 because it's kind of going straight down the middle. So if I were to draw a right triangle to figure out what that slant height is, I'm going to go ahead and divide 62 by 2 because this height right here is going right through the middle, which means that the bottom side here is actually going to be 31 meters instead of 62, okay? And now we're trying to figure out what the slant height is, which is C in our right triangle. So now we use Pythagorean theorem, okay? The most difficult thing about these application questions is figuring out what goes where and what part of the problem. Like for example, some people may not have noticed that, oh yeah, you have to divide 62 by 2 to get this side down here, okay? So that's probably the most difficult part of Pythagorean theorem application questions is figuring out what goes where. But once you have that down, it's very easy. You just plug everything in, just like you guys know how to, and solve. So I did 31 squared and I got 961. And now I did 62 squared and I got 3,844 equal to C squared. I'm going to add those two together and get 4,805 equal to C squared. Take the square root of 4,805 and get 69 point, round to the nearest tenth of a meter, so 69.3. Okay, your answer is 69.318107, a bunch of other numbers, but since we're rounding to the nearest tenth of a meter, then we're going to round that to 69.3. Okay. Another example. So we have a builder that makes a drain pipe. A builder makes drain pipes that drop 1 centimeter over every horizontal distance of 30 centimeters to prevent clogs. So, okay, so a builder makes drain pipes. Okay, so basically what's happening here is the drain pipe is going to drop 1 centimeter for every horizontal distance of 30 centimeters. So horizontal, we know, goes side to side. So every time that your drain pipe goes 30 centimeters horizontally, okay, you're going to drop 1 meter. Okay. Now we have a certain drain pipe that needs to cover a horizontal distance of 600 centimeters, okay? So our drain pipe, the length of the drain pipe is basically this part right here, right? That's how long the drain pipe is. So what we're trying to figure out is, since this drain pipe has to cover a horizontal distance of 600 centimeters, I want to figure out how far it's going to drop, okay? So to do that, we know that it's going to drop 1 centimeter for every 30 centimeters, which means that I'm going to go ahead and divide 600 centimeters by 30 centimeters so that I can figure out how far it's going to drop, okay? Because every 30 centimeters, it's going to drop 1. So when you do 600 divided by 30, you get 20 centimeters, which means I can go ahead and basically draw a triangle similar to this one, where the side, or the distance that it drops, instead of just being 1, right, it's going to be 20 centimeters, okay? And remember, our horizontal distance was 600 centimeters, okay? So now from here, we're going to go ahead and figure out how long that drain pipe needs to be. So we're figuring out L over here, or C, right? And yet again, go ahead and use Pythagorean theorem and plug everything in, okay? I'm going to move this thing over here. Okay. So we have A and B. We're trying to solve for C. 20 squared, B is 600, equals C squared. 20 squared is 20 times 20, which is 400. And 600 squared is 600 times 600, which is 360,000. Okay, we're going to add 400 to that to get 360,400 equal to C squared. And then take the square root of that on both sides. So that C is about, we're rounding to the nearest tenth, so we'll do 600.3 centimeters. Okay, so our drain pipe here is going to be about 600.3 centimeters long. Okay, so like I said, the hardest part of these problems is figuring out what goes where and how to interpret the problem. Okay. All righty, y'all. So if you guys have any questions, you can go ahead and leave any comments below and I will get to you as soon as I can. And I hope y'all have a great week, and I'll see y'all in another video. Bye.